Yeah, good morning, everyone. Welcome to the session on Observer Pattern. First of all, thanks to all of you for joining us on the Saturday morning. Today we'll be discussing about Observer Pattern. So, agenda for today's meetup will be: what are the general problems that an Observer Pattern can solve? What design patterns are? Then we'll briefly look into Observer Pattern. We will try to understand this pattern with some analogies and examples. Then we will dive into the code examples. We will directly code a solution using an observer pattern. And in the end, we'll look some of the pros and some of the common variants that we have with observer patterns. And at the last, I will share certain resources that can help you out to learn more about these patterns. Before moving on, thanks a lot to Pune Developers Community for hosting this meetup. So this community is of all the tech enthusiasts of Pune. It continuously organizes meetups and events on different technological topics. So you can check out their meetup pages. You can join this group, and you will be notified about all the upcoming events. You can also follow the social media pages to get updated with all the events that are happening. So once again, thanks to Pune Developers Community for organizing this meetup. Before moving on, if you have any question, you can just post them on the chat window. I will try to resolve them out. I will try to answer them out one by one. So you can post your question if you have any time during the session over in the chat window. Okay, so let's get started. So let's have a quick look on the problem statement that we are going to cover. I have created an imaginary problem statement to understand observer pattern with more detail. So we are supposed to develop a pseudo application for a smart home where there is a centralized sensor to measure the temperature. And the requirement is that whenever the sensor reading changes, whenever a new temperature is recorded, multiple home devices should get notified. It could be a fan, heater, refrigerator. Other devices should get notified. And the thing is, our application should be extensible enough such that in future, if any other device wants to use this sensor reading, he can use it. And if any existing device doesn't want to use it, he can leave it anytime. So if we visualize, there is a centralized sensor which records the temperature, and there we have a multiple other devices uh, which can change arbitrarily, and we need to notify them as soon as this recording changes. So as soon as the state of this sensor recording change, we need to notify other objects. So if you see, this is a very common problem we often encounter in our development work. Some similar problems that I'm sure you must have faced while doing the development is, let's say you just have a toggle button on your screen on your UI, and whenever user change its state, you need to inform some other parts of the application, or maybe multiple parts of application. It's whether it's a web application, desktop, mobile, you must have seen such kind of requirements. Also, if we have worked on MVC pattern based application, whenever our model changes, whenever our data changes, we need to update the view as soon as the model changes. Also, in event based application, whenever an events get triggered, we need to modify other parts of application immediately. So this is a very common problem we see, and if we abstractly define it in summary, there is a whenever a state of an object changes, we need to inform multiple other objects. So for such problems that are very common into our development, there are design patterns. So what design patterns are? They are like a common solution for commonly occurring problems in a software design. So whenever we have common types of problem, we have a generalized solution. It's not like a typical algorithm or a piece of a code. It's more over like a best practices or a guidelines or a concept that you must follow to solve your problem. There are tons of types of design patterns for all kinds of problems. There are lots of them. Majorly, we can categorize them into three categories: behavioral, structural, and creational. Today, we are going to look into one such design pattern which can help us the problem statement we have for the smart home application, and that is an observer pattern. So what observer pattern is, it's a behavioral design pattern in which there is a subject, there is an object called subject, and whenever its state gets changed, whenever one of its variable gets changed, it needs to update multiple observer. And how does it do it? It maintains the subject maintains a list of all the observers, and whenever its state gets changed, it notifies them immediately. And how does it notify? It usually do it by calling one of their method. So that's in a very brief manner observer pattern. I know many of you, if you're looking for the first time, it sounds little confusing. So just for we can understand it more briefly with the help of an analogy. So observer pattern are very similar to how a magazine subscription works. Okay, let's say there is a publisher who publishes a magazine weekly or in some other period. What you can do, you can subscribe to that particular publisher, and whenever there is a new edition of a magazine, you will get delivered immediately if you have subscribed to that magazine. Also, you can anytime unsubscribe, and as soon as you unsubscribe, you will not get the latest magazine. So this is the way the publisher maintains a list of all its subscribers, who are the people who have subscribed, and whenever a new edition comes, he delivers that magazine to all of them. Whenever someone unsubscribe, the publisher remove that from the list, and you will not get notified. So this is how a magazine subscription works, and the observer pattern is pretty much similar to the magazine subscription. Let me know if you have any questions so far, uh, about any question about observer pattern. Feel free to ask any question if you have any time during the session. Let's make it more interactive session. Okay. So moving ahead, this is how we understand observer pattern. Now let's look into a code example to understand it in much depth. I will try to keep it very simple so even a beginner can understand it. And also if you are if you have used, or if you're an experienced developer, it will be more or like an refresher for you on the observer pattern. Before moving on, let's revisit our problem statement that we have. So we are trying to solve this problem. We need to develop a pseudo application for our smart home application where there is a centralized sensor, and whenever its temperature recording gets changed, we need to inform multiple home devices such as fan, heater, etc. And its application should be extensible so devices can connect or disconnect from the sensor anytime. Okay, so let's dive into the code example. I will be solving with the TypeScript. Just information, design patterns are not specific to any language. You can do them, you can use them in any language. They are not as language specific. They are just, as I said, they're just general concept, general guidelines. So you can use them in any language. Here I'm using a TypeScript language. I hope my screen is visible. The fonts are visible. Let me know if the fonts are not visible to you. I will increase the font size. Okay, so moving ahead, here we have this sensor class, and there we have this fan class. So in the sensor, it has a private variable temperature which measures the temperature, and we have the setter class set temperature to update the temperature recording. And what I need to do whenever this temperature gets updated, I need to inform my fan class, the object of fan class. So let's see how we can do this. Before moving on, so here we have this sensor will act as a subject that will inform multiple other observer, and here the fan class will act as an observer. It will observe the sensor class to read its temperature value, to get its temperature value. So before moving on, let's create two interface. One interface for subject, and let's create another interface for our observer. Okay, so subject interface needs to have three methods, at least three methods they need to have. One is to register observer, since they need to maintain a list of all other observer. So they need to register any observer which. Next we have unregistered. So if any observer wants to get does not want to get informed about the readings, he can unregister at any time. So we have unregistered method. And the third one is notify observers. So whenever it will notify all the observer about the recording change. So the subject interface needs to implement these three methods for functioning. An interface observer needs to have a method called update, which will get a data from the subject. So what will happen is register and unregister, the observer can connect to the subject, and using notify observer, subject will inform all other observers. Okay, so let's implement this sub interfaces in our classes. So sensor implements the subject interface. Sensor is our subject. You can see here is a warning. So we need to implement all these three methods. Okay, great. So here we have register observer to unregister observer and notify observer. So look how a subject will maintain a list of all its observer. So let's create a list observers. It will be list of observer. So a subject will have a list of all its observer, and whenever someone wants to register as an observer, we can just simply push them into this list. And in a similar way, whenever any observer needs to unregister, we can simply find out its index, observers dot index of O, and we can remove it using. We can remove this from this list of all its observer. So what we have seen over so far, the subject maintains a list of observers. It can add any observer to this list and it can remove it. Now comes an next important part, like how to notify this observers whenever there is a change in our state. Let me know if you have any questions so far. Okay. So now we need to inform all our observers. So whenever the sensor recordings change, we will just loop in. And we will call a single class that all our observer interface implement, that is this update class. Update, and we will pass this temperature data to them. It will loop in through all its observer it is monitoring, and it will just update them. Next up, we need to, whenever we are setting this temperature, we need to notify observer. So we will call this method over here. So that's all for our sensor class, which implements a subject interface. It maintains a list of observer. It can add an observer, it can remove an observer, and using a for loop, it will inform all those observers. Okay, so moving ahead, next up we need to implement this interface observer over here in fan. So let's implement observer. Fix, implement this. So you can have any logic, but here I'm just simply logging it up. And new. Okay, so but before, along with this, we also need to register this fan class with our sensor class. So to do this, we'll maintain the list of a subject, and in the constructor, that is sensor, and I will register to the subject sensor dot register observer, and I will pass with this object. So this is a pretty simple fan class that we have. It just, and in a time of initialization, it will register to the observer, and whenever it will get a new recording, this method will get called update. And we can have any other further business logic. I am not implementing as of now, but we can have more such logic over here. That's pretty simple to get started. So we have these two classes, sensor and fan. So let's see, let's have some driver code. We will initialize an object of a sensor and a fan. In fan, we need to pass this, whichever subject we need to subscribe. And here I am just setting a temperature of my sensor class. So let's see how does it runs up. First of all, I need to compile my TypeScript code to JavaScript, and then I will run my JavaScript code. Okay, there is some error. Okay, so here we have not create an empty list. So error. Okay, so as soon as the sensors measured the new temperature, the fan update method got triggered, and it got a new temperature data. As soon as we have another temperature data, the fan got notified again. Right. So this is what happening. The state of one of our object, that is the sensor object, is changing. Its state temperature is getting changed, and as soon as it gets changed, the fan object, the other objects get informed, and that's what we do with the observer pattern. Let me know if you have any question. Okay, there are certain questions. So okay, so number, Ajay, number is a data type in TypeScript. We do not have like an integer float. We just have a general number data type in the TypeScript. Okay. Okay. So now the beauty of this beauty of this observer pattern is you can add as many observer as you want without disturbing the logic of this subject class, right? So even if I need to implement another object, let's say heater, I don't need to make any change to my sensor class. I can just directly do this. Right. Let's have some pseudo business logic as well to get understand it more better. So if let's say temperature is more than 30, we can say it's hot, turning myself off. Otherwise, you can have any business logic based upon it. That's completely up to you. I'm just using this dummy logic. It's cool. Right. So to create this new observer, we did not need to make any change to the subject class. We just need to create a new class and it will directly work. Right. So that's the beauty of the observer pattern. Your subject class does not need to modify. You can create as many observer in a runtime, and you can also remove them in the runtime. To remove them, that's why I have kept this. I have kept this reference of subject. So if I need to just remove it anytime, I just need to call. Let's say if I have to remove it, just give an example. This dot subject dot unregister observer. You just need to. You can anytime unregister as well. Let's see how it works up. We have two observers as of now, fan and heater. Okay, so I have not updated my driver code. That's why. Let heater. Okay, so as you can see, as soon as the sensor gets new data, the fan get notified, as well as the heater object gets notified. Since the temperature is too large, it gets off, and when the temperature is low, it automatically gets turned on. So similarly, we can create more objects for any devices, and it will work seamlessly. Any question? Okay, so Manjeet has asked, why do we need to unregister an observer? So it could be a reason. Let's say I have this AC or device. It is initially connected to this temperature sensor, but tomorrow it wants to not connect to it. Rather, it's want to connect to a humidity sensor. Let's say. So it could be a requirement that we do not want to be registered. And as we have seen in analogy that we have a magazine subscription, how magazine subscription works, you might be subscribed to one magazine for a time, but maybe your interest get dropped down, and then we can move on to any other magazine. So just to keep these things flexible, we have such kind of register and unregister of thing over here. Yes, Kushal, it's the first session with design patterns. Let me know if you have any other question in the chat window along with the code, over the code. So I will again quickly go through the code to summarize what we have done so far. We just had a two class, sensor and the fan. Whenever the sensor data, this temperature gets changed, we need to inform the fan and many other classes. So first of all, we created this two interface. The subject interface at minimum needs to implement these three methods: register observer, unregister observer, and the notify observers. And all our updated observer interface needs to have this single method called update. And here in the sensor, I'm just maintaining a list of all the observer. You can use any collection to maintain a list of all the observer. And I will just looping through all these observers and calling their update method to send them the new temperature data whenever I have a new temperature recording. And my observer just simply needs to implement this update method, and it can have any business logic anytime. Okay, so Kushal has asked, can observer subscribe to multiple subject? Yes, that could be one scenario. That could be one of the variants. In this example, we haven't done it like this way. We have made a structure such that an observer can subscribe to only one subject. I can show you how it can be done. If you need to subscribe, let's say if you need to subscribe multiple subject, so you just need to know which subject is calling this method. Okay, over here you can just know which subject is calling this update method. You will get this context, and using which you can you can connect with multiple subjects as well. So this is one of the variants which you can have. But over here in this example, we haven't kept it to keep it simple and easy to understand. Okay, so moving on, we have solved a problem that whenever the sensor recordings change, we need to update multiple devices. And moreover, we have kept our application extensible so that any device can connect and use this, and any device can stop using this recording. Let's quickly look into the UML diagram. We have this observer interface and the subject interface. There are the concrete observer classes which implements this update method, and a subject class, subject interface need have this observer collection, and it has a three methods: register, unregister, and notify observers. And as a logic, it is just looping through all these observers and calling their update method. Pretty simple, but pretty powerful. As we have seen, this is a very common problem we see, and this observer can, this pattern can help us to address those problems. Now let's look into why we have attempted this problem with only this particular way. So the reason to do this is to establish a loosely coupled link. Whenever we use observer pattern, it establishes a loosely coupled link between subject and the observer. So what I mean by loosely coupled is that the subjects are totally unaware about the observers and observers are totally unaware about the subject. When I mean unaware, is about the concrete class. How they, what they know about them, that they just implement a particular interface, right? If you have seen, my subject never, my sensor never knows like whether it's a fan, whether it's a heater, whether it's a refrigerator, what it is. It just needs, there is an observer. Okay, so that's a good thing. If we should always try to code to the interfaces and not to the concrete classes, and that's what observer pattern let helps us do. Second thing, we can add new observer easily, and we can also remove any observer at any point of time. A very good thing. The third very best thing is we do not need to touch the subject class at all, if even if we want to add a new observer or any new type of observer, right? So our subject class is open for extension but closed for modification. We do not need to modify a subject class for a change in observer class. So we have achieved, this is also one benefit we get with the observer pattern. Another good thing is the subject and observer are independent of each other. Okay, so even if I do not have any subject, my observer will still act. Even if I do not have any observer, my subject class will still act, will still remain as it is. Okay, so this is all good benefits you got with the observer pattern. Okay, so this is Mahadev is explaining design graph. Okay. Okay, so this is all other pros that we have with the observer pattern. The thing is, this subject is totally decoupled. There is a very loose coupling between this observer and the subject, and that's the benefit we get with the observer pattern. Also, the subject just knows about this observer pattern and not about this concrete classes. Then we do not care about this concrete classes over here. We just care about this interface observer. So this benefits makes it the a solution with the observer pattern really scalable and a good enough for multi of our problems. But yet there are many common variants. Okay, as I said, this design pattern, observer pattern, is not a specific piece of a code. It is just a general guideline. It is just a general solution or best practice that you can use. So you can modify, you can tweak this observer pattern as per your requirement. So someone has asked, can we have a many subject, many observer? Yes, an observer can observe multiple objects at a time. Okay. Also, there is another common variant where the observer triggers the update. Okay. So let's see the state of subject changes too frequently. Okay, our temperature recording is changes every second. So that's too many updates call will be happening. So in such case, when your subject is changing too frequently, you can have the other way around and the observer triggers the update methods. Another common variant is the push and pull method. What we are doing over here, the subject is sending all the data to the observer. But let's say if the data being passed is too much high, we can do the other way around, that the subject only informs that yes, there is a change in my state, and then let observer decide what data it wants and whether it wants data or not. So that is also one of the common variants that we have in observer patterns. Okay. Okay. So Manjeet has asked, what do I mean by concrete class over here? Okay. So concrete class is this fan class. Okay. This heater is a concrete class. Okay. And when I say the interface, this is an observer, right? So what is an issue? Let me tell you with the code. The other way to solve this problem could be, I could have this within this set temperature. I can have this fan object and I can call its update. I'm just giving an example over here. Similarly, I can have a heater object and I'm calling its update method. Okay. So in this way, we are connected to a concrete class, to an object of a concrete class. The problem with this solution is whenever there is a new observer, you need to create that new observer, you need to modify, you need to update it. Even if you want to remove it, you need to come to the sensor and you need to remove it, right? So these are the challenges if we code along with the concrete class, right? And that's why it's better to code along with the interfaces. And that's what I mean by concrete class to have a over here. I hope it answers your question, Mahadev. Okay, yeah. Any other question or any other part you want me to revisit? Okay, yeah, Rohan, that's a very good question we have over here. Publisher subscriber messaging are pretty much similar. It's very much seems similar to observer pattern, but yeah, they are not exactly similar. Okay, let me show you an example over here. What is happening over here in observer pattern? The two objects are directly connected. Okay, there is a direct connection between these two classes. Whereas in the publisher subscriber pattern, which is also one of the design patterns only, they are not directly connected. Rather, what they have is they have an intermediate queuing service, message queues bus in between in this part. Okay, and that's what. Let me show you an example. Okay, so there is this message queue in between, which handles all this data coming from this publisher and when then there where it's coming from subscriber, and that is used for a particular different kinds of problems. So they have some similarity, but they are different patterns. Okay, any other question? Okay, so moving ahead, there are some suggested resources you can check out. So design patterns, as I said, they are the general solutions to commonly occurring problems, and there are plenty of design patterns available, which you can use as per your own needs. And there are also many variants available. So here I have some suggested resources you can check out. There's this very good website called oodesign.com, which covers all the design principles and all the design patterns. You can check out this website if you want to check further about other design patterns as well. Also, there is this website called Refactoring Guru. This is also a very good website, and they explain all these design patterns within using very good graphics and interactive examples. The good thing is they have a code solution in all the languages. So if I go to this observer pattern, you can see they have the codes examples in all the common languages available. So you can easily check in the language you want to understand it better. And this is another good book as a beginner you can start with is the Head First Design Patterns. They cover lots of interesting analogies and lots of examples. If you have read earlier the Head First books, you must already know like how different these books are. So you can check out this book as well if you want to further look into the design patterns thing. Yeah. Okay. So that's all, guys, for today. Let me know if you have any query, any comment for me. You can mail me over here at on my email ID. I will post the link to this slide and to the code in the comment section later on, so you can check them out anytime. Feel free to ask if you have any other question. Thanks a lot for joining us in the Saturday morning. Once again, thanks a lot to Pune Developers Community for hosting this meetup. I will request you all of you to join the meetup group of Pune Developers Community. Also, suggest your friends and your colleagues to join this group so you can also get benefit of the multiple technological sessions we are having every week. Yeah, that's all for today. Thanks a lot. Thanks a lot for joining.